Which functional group reduce easily among aldehyde, ketone, ester, and carboxylic acid? All four have carbonyl carbon. So the more electrophilic carbonyl carbon will reduce easily than less electrophilic carbon. Okay, if you see the ease of reduction, aldehyde is more aldehyde easily reduced than ketone, and ketone is more reactive than ester, and alcohol and carboxylic acid is least reactive. Okay, yani why aldehyde is more reactive? Because the carbonyl carbon of aldehyde is more electrophilic in nature as compared to ketone, because ketone has two electron donating group, which which stabilize the carbonyl carbon. As a result, it become less reactive as compared to aldehyde, where only one electron donating group. Okay, on the other hand, if we see the ester, there is methoxy is present next to, there is a alkoxy or methoxy is present next to carbonyl carbon, which is electron donating. The electrophilic center of carbonyl carbon is activated by methoxy group, which provide electron, and it reduce its electrophilicity, which electrophilicity decrease हो जाएगी. As a result, its stability will increase, and you know very well, the more stable is less reactive in chemistry. If we now, the question is, which reducing agent will reduce lithium aluminum hydride and sodium borohydride? Lithium aluminum hydride is one of the powerful reducing agent, as we know that it reduces all functional groups and easily into alcohol, direct into alcohol. Okay, it and not only reduce the least reactive carboxylic acid, but it also reduce the ester, aldehyde and ketone to corresponding alcohol. इन सबको डायरेक्ट अल्कोहल में कन्वर्ट कर देता है. But if I want to do some selective reduction, then we must use sodium borohydride, which is mild reducing agent. It only reduces aldehyde and ketone functionality, while it cannot reduce ester and carboxylic acid. Carboxylic acid and ester are considerably less reactive reduction than aldehyde and ketone, and require the use of lithium aluminum hydride, LAH. Okay, now the question is how this reduction carried out. As we know that the key steps in the reduction is the reaction of hydride with carbonyl carbon. Both sodium borohydride and lithium aluminum hydride just transfer hydrides. Hydride is electronegative, यानी it act हाइड्रोजन के ऊपर नेगेटिव चार्ज आता है, which act as nucleophile. It attack on carbonyl carbon, which is electrophilic in nature, and alkoxide will form, which convert into alkoxide ion. This alkoxide ion is, and proton is abstracted from water. As a result, alcohol will form. So this is all about the mechanism of this reaction. But lithium aluminum hydride reduce all functional groups into corresponding alcohols and other reagents, but sodium borohydride is the selective one that only reduce aldehyde and ketones. If you have any question regarding this topic, you can ask question in comment section of this video. Subscribe the channel and bell and press bell icon. Thank you very much.